Lesson 26 is about the one and only one integral technique we'll be using in this class, which is called U substitution. U substitution is used to handle composite functions. Meaning when the integrand inside the integral that you have is a composite function, then we can use this technique, U substitution, to handle the integral. Okay, before we get to that, we should review what is a composite function, and when we take the derivative of a composite function, how we apply the chain rule, right? Okay, so composite functions are functions that has two layers. So for example, if I have f of x equals sine of x squared, this is a composite function. Okay, and by looking at this, you can see that there is an outer function which is the sine function. So I'm gonna say this, the outer function is y equal to f of u, and f of u is defined as the sine of u, right? And then there's an inner function which is the u function, and u, that's called g of x. This is a squared function. So now when I take the composite, I look at f of g of x. So now I just plug the g of x into the u, right? And then plug the x squared into the g of x. So I end up having sine of x squared. All right. Okay. A quick way that you can decide whether you have a composite function or not is said if it is a composite function. Is you can try to do a quick evaluation. Okay, so what does that mean? For example, let's say we want to evaluate f of 2. Okay, so this is sine of 2 squared. So for you to do such an evaluation, suppose you can use a calculator, then what is the steps that we'll be using? So you're gonna first do what is 2 squared, right? So 2 squared is equal to 4. So this is your step 1. And then you have step 2. So you use the 4 that you just found and then plugged it into the sine function. And then you get a value, right? Okay. So whatever you have to do first would be the so-called inner function, and the part that you do later, that will be the so-called outer function part. Okay, so that's an easy way you can decide whether you have a composite function or not. Okay, so let's compare the sine of x squared with, let's say, y equal to x cubed. So if right now I want to evaluate y of 2, what happens? Then I simply have just one step, 2 to the power 3, which equals 8. So this is not a composite function. Okay, so we discussed this when we talk about the the chain rules. Okay, so you can go back and review that part. But this is just a quick review. All right, so let's continue use this function f of x equal to sine of x squared as an example. And now to find the derivative, we need to apply the chain rule. Okay, so how do we do that? So first, you're gonna set up a outer function and inner function. So the outer function, as we discussed, we have the sine of u. So this is the outer function. And now u being x squared, and this is the inner function. Okay, so the derivative f prime of x is also dy dx. Then this is dy du times du dx. Okay, so if we go back and visit what do we have here, according to y of u, then dy du is equal to cosine of u. And over here we have du dx equal to 2x, such as that. All right, so now we plug these two results into the equation. So I have cosine of u times 2x. But remember, when you handle the composite function and apply chain rule, you always need to convert the u back into x. So then we have cosine of x squared, because u is equal to x squared, times 2x. Let me reorder it. So I have 2x times cosine x squared. All right. So this is how you apply the chain rule to find the derivative of a composite function. So now if we talk about antiderivatives, or let's say indefinite integrals. Okay, so from this example here, we can tell that, oh, the function sine of x squared has a derivative equal to 2x cosine x squared, then plus any constant c, right? Okay, so u substitution is a technique that helps us to handle a situation like this. When you have the integrand as a result of a derivative of a composite function, how do we have a more systematic way to find a antiderivative of such a function? All right, so this is just a quick example. We're going to talk